Okay, this is Leetcode 5, the longest palindromic substring. So, for example, we could have a string as input, like A, B, A, B, B, A. So palindrome is starting from the center of a string. You kind of expand left to right, and it has to be equal to each other. So here, a palindrome is like taco cat, right? You start at like O, and you go left one, right one, C, A, T, T. So taco cat is a palindrome, and then what's also common is a anagram, which is taco cat is also an anagram as well, I believe. So anagram has an equal amount of characters in the string, or you can rewrite this word in a different order, and it'll have the same characters. So like an anagram of taco cat would be like TT, AA, or AC, ACO. These are anagrams of each other. So yeah, so the palindromic substring, I don't know why I just talked about anagram. But yeah, so in here, the longest palindrome, let's see. So A is a palindrome, just the letter A, the character A. So is B. And then from B, we see that the left and right indexes both have A in them. So we can say that this is our current longest palindrome in this substring. And we're doing substrings here, not subsequences. I know that there's another problem that involves subsequences. And then we can go further. A, and then B is not equal to the empty string. So maybe we want to move to the next one. And A, B, B is also a long substring. That's the same length as our previous one. And then just kind of looking at it, we can see that anything is just going to have the greatest length that this is going to have for longest palindrome is going to be 3. So we can either return ABA or BAB. Yeah. So working with that, we're going to be actually going over something called manachers algorithm, and I don't know how to pronounce it, but it's Manacher. Manachers algorithm, I actually just saw a video of this online, so I'm just going to be going over the code that they got. And this is, for me, it's just practice as well. I actually just did this problem today, and I'm still trying to figure it out, so I think drawing on the whiteboard kind of helps me go through that problem solving process. So basically what you want to do first is, like, given a string, let's just say the string is A, B, A. Yeah, we'll just do a short example. So what you want to do here is, like before, I checked from A and then to the right of A and then to the left of A. But what we want to do is we want to modify this string so that it's easy for us to delineate where we're searching. So like here we search A, but then we also might need to search like right here in between A and B, because if they're the same thing, like let's say we had string A, B, A, right? We're starting from A and then we're looking at the index of A plus 1, A minus 1, they're not equal to each other. So we go to B, and then what do we do here? We're looking at B, and then we're looking at the next B to the right, and then A to the left, and then we're seeing they're not equal. So by that same logic, we just move to the next B, and we see that this B is not equal to that A, and then we would just keep moving. But actually, this whole string is a palindrome. So we need a way to delineate the middles between each characters. So the way we do that in manachers algorithm, manachers, we actually, in Python you could just, I think this is easily readable in Python. So what you do, or what I did, was you have like a start character. I just use like a $, and then a number sign, a pound sign, and then you're going to add it to, what was it? I just said C for C and S. So each character in the string that we're given, yeah. You have to join it with something. So S equals $pound plus pound dot join C for C and S, and then at the end we also need to give it another pound sign. There might be a better way to do this, but this is how I'm doing it. And then the end character, I just use that sign, because that's what they use in the example that I looked at. So this is going to give us, this is going to give us this. String is that, number pound sign, A pound, B pound, A pound, B pound, A, at, pound at. Okay. Yeah, it's going downhill there, but that's what S is. Right now I'm gonna erase this. So what we need to do here is we need to keep track of the center of what we're looking at, but we also need to have a right border and a left border, and then use our current index to adjust our right borders or not. So what we're also going to do is create another array that's the size of S, the new S, and this array is going to keep track of how many what is it? So when we're starting at A, the pound sign is equal to the pound sign. So that is a palindrome, including the pound signs. Palindrome of length 3. And then in each direction are going one way, 1 pound sign, and then to the left 1 pound sign. So we're keeping track of, from the center of that index, how many times we go one way, and it's still a palindrome. So I can initialize, like they called it P, I guess for like palindrome array. We'll set that to 0 times the length of S, and then S is this, not that. Yeah, actually I think it's better to rename that. I believe they called it T. Yeah. And then we'll say instead of length of S, because we actually want to use S later. So length of T. T is this, palindrome is that. So P is now going to be all of this at 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Perfect. So now what we're doing is, let's start writing our function. Define longest palindrome. So we have that string that we're given. And then, like I mentioned before, we want to initialize the center. Call it cen, C-E-N, and then R, which is a right border. Let's call it right. They're both initialized to 0 at first. And then let's just pretend that we have T already, that T equals that string. So I'm just gonna that's going to be here. And then same for P as well. So now that we have that, we need to iterate through T, right? So for I in range of length T, this is going to be T minus 1, right? So this is where it gets tricky, and I'm really trying to solve it instead of just remember my solution. Right, so we had some sort of mirror. I'm remembering right now. So mirror was equal to 2 times the center minus I. And then we have a, so what do we do here? We have a mirror, and then we need to check if I is less than R. If I is less than R, the right border, if I is less than the right border, then we need to set P of I is equal to the min of R minus I, or P at mirror. And then after we do that, we need to do a while loop. We need to check. And I actually made a mistake here when I was doing this, so I'll try not to make it again. So, what do we loop and do? Right, so we're going through T. I'm writing too big, I think. Okay, so while T of I minus 1, so we're going to the left, so we're comparing, just pretend we're at this element index, which would be index 2. We need to check index 1, and 3, we need to check if they're the same. And we're not going to just use I minus 1, because we need to keep, or we can't change I here. So I minus P of I. Well, that is equal to T of I plus 1 plus P of I. Yeah, before what I did was I minus 1 plus P of I, and then I plus 1 plus P of I. But they both need to have the same operator. And it's a square bracket there. So while they're the same, we want to increment P of I plus equals 1. So that's what it's doing. So at this index, P of I should be 1. And then at this index, it should be 0. At B, it should be 1, 2, 3, because they're the same. So that's what we'll see is going to happen. And then we need to check, well, I is less than R. No, it's not. If and here we need to check if P of I, if P of I, so we need to check if it's within our right border. In a minute. Let's see. So let's say we're incrementing I. We need to do, and we have center and the right as well that are first initialized to 0. So in this conditional, we need to make sure that we're updating the center and our right. Yeah, so I think it should be if P of I plus I is greater than R, we'll set C, center, is equal to, center ended in here. Center is equal to element at I, and then R, right, so we're doing P of I plus I, because, so let's say this is I, right, and then we're moving P of I times, this is going to have P of I times the palindrome length, and if the right border is going to be, or the right border should be that length plus that index. So this would be our right border. And then we're going to just continue incrementing our right border based on where our center is. Yeah, so R would be equal to P of I plus 1. Sorry, plus I. And then actually I'm not actually getting the longest palindromic substring here. I definitely ran so I guess you could write in like 2 lines. But what we want to do is eventually, let's just run through the code and then I'll get there. So yeah, this looks a little messy, so I'm just going to rewrite this. Yeah, I'll rewrite it here. I'll write it a little smaller too. T, yeah, okay. I have that here, yeah. And I'll try to line it up with P as well. So T is equal to $, pound A, $, or pound B, pound A, pound B, a pound. And then I'm actually missing the 0 here. But that's okay. So yeah, we'll go through it. Center and right are initially here at the $. And then so for I in range, like the T minus 1, the mirror is going to be equal to 2 times 0 minus 0, which is just 0. If I is less than R, so the first iteration I is 0, C is 0, R is also 0. So I is not less than R. And then while we're going into this while loop now, we're checking if we can expand out using our 0th index as the center, if they're equal to each other. They're not. This is not going to be out of bounds because it's just going to do, in Python, it's going to go negative, so it's going to check one of these indices. And we're going to see this P of I plus P of I 0 plus 0. Is that greater than R? No, it is not. So we go to the second iteration, I is equal 1. So mirror is now equal to 2 times 0 minus I, which is again negative 1. I is 1, I is not less than R, so we'll go to our while statement. So yeah, we're at this, over here. And while the left index, left element is equal to the right element, no it is not, we'll break out again. P of I plus I is greater than R now, so we're going to update our center to be at element I. Center is now here. And then we're going to increment our right border over to P of I plus I, which is also just here. So moving that. So we move both in center to index at 1. And then next iteration, 2. Mirror is now equal to center, which was updated, right? So these were both updated to 1. So mirror equals 2 times 1. 2 times 1 minus 2, which is still 0. So is I less than R? 2 is not less than R, no. So we'll go back to that while loop. And now we're searching. So I is here. Like this. And we want to go left and right. And these are actually the same, right? Pound is equal to pound. So what we do is we increment P of I here. Is P of 2 by 1. And then we try again. $sign is not equal to B. So we break out. And then if P of I, 1, plus index is 2, 3 is greater than 1. Yes, it is. So we update our center and update our right border. So center is now at index 2. And then right is going to be P of I plus 2, which is 3. P of I plus I, which is 2. Yeah, which is 3. So R is now different than our center. 3, yep. And then we'll go again. I is now 3. Right here. And mirror, we're going to update mirror to 2 times center, which is 4, minus current index is 4 now. So, no, it's 3. I already updated it. 4 minus 3 is 1. So mirror is 1. 3 is not less than 3. So again, while loop, A is not equal to B, break out P of I plus P of I is 0 plus I is 3. 3 is not greater than R. We don't do anything here. So now we can increment 4. Now we're here. So this is going to be a similar case actually. So yeah, 2 times center is still 2, minus I is 4. Or minus I is I is 4. Yeah, so 2 times 2, 4 minus 4 is 0. Sheesh. 0. And we actually don't need to keep updating this, I guess. But yeah, I is 4 is not less than R. While they're the same, pound is equal to pound. Okay. So we're going to be updating P of I here. It's going to be at least 1. Just leave that down there. It's going to be at least 1 here. 2, 3, and these aren't the same. So 3. So B, P of I at B, P of 4 is 3. So P of I plus 1, which is 3 plus 4, is greater than R, definitely is. Then we'll update our center to be at I, which is 4. Yeah, I is 4. I just wrote 5. Center is 4. Yeah, I guess I should have written the indices down here. I guess that would be easier to follow. Something to do next time. And then we have to update our right pointer as well. Just 3 plus 4, just 7. And this makes sense because this is where our like center is, and then if we like put a mirror right inside of B, you could go out, expand these ways. It would be at, we'd go 3 times, right? So, and this is at index 4, index 5, index 6, index 7 is where our right border is. So I hope you can kind of see the pattern and what that looks like. Center, and then mirror. That's like the analogy they use in the video that I saw. Yeah, so we did 7. Now we're at 5. Right here. You can see that B and A is not equal together, or not equal to each other. Yeah, I is 5. 5 is less than R this time. So maybe we want to know what the mirror is. So the mirror is going to be 2 times center, which is 4. So 2 times 4 is 8. Minus 5 is 3. The center is 3. I is less than R. Yes, it is. 5 is less than 7. So P of I here, we can actually just update it using this because we've already seen this before. So if you just look at this outside, you should see this pattern, but since it's a mirror, you should see P of I being equal to the similar value from the other side of the mirror. It's 3 is 3, 0 is here, so we should see another 0 here, since we had 3 here. And then we should see a 1 here because we saw a 1 here. So that's kind of, or we should see not a 1 here, but we should see at least a 1 here, because the palindrome could potentially expand further. But yeah, so mirror is, I updated this when I shouldn't have, huh? This was 4. Mirror is 3. Yeah, so P of I here is the min of R minus I, which is 7, minus 5, which is 2. So it's either 2 or P of the mirror, which is P of 3. So it's the min of 0 or 2, which is going to be just 0. So we can leave it at 0. And then after that, it's going to check. It's going to go to the while loop. B is not equal to A. P of I is 0 plus 5. I. 5 is not greater than 7, so we'll go to our next iteration. And this is, just based on looking at the example, this is what the midpoint of our longest palindromic substring should be. So this should be an interesting example here. So I is now 6. And then the mirror is going to be 2 times the center, which is 4. 8 minus 6 is 2. There's 2. I is still less than R, right? So it's going to be the min of 7 minus 6. 7 minus 6, which is 1, or P at next 2. So 1 or 1. It's going to be 1. So we're going to update this to be 1. And then we're going to still hit this while loop. So while these are the same, increment by 1. So 1, 2, 3, 4, 5. So P of I is going to be plus equal to 1. So 1, 2, 3, 4, 5, 6. Minus I. 7. P of mirror is 1. So this is going to be 6. And then we're going to update the center and then the right. Center's here. And then this is supposed to have a ending character. And then the right is going to be here. All the way over here. And then eventually this is actually, I'm just going to skip through it, but you're going to see that using the center and then the mirror, we can just quickly get these as 3, and then 1, and then 0, 0. So now that we have the center here, and actually I think it should be 5. There may be a mistake. Maybe in the code, or maybe in my run through. I'm gonna have to go back and check. But yeah, based on this, you can easily kind of keep track of what index you are, and also the count here. And then you would have to divide the count by 2 from because the first string that we're getting the longest substring, and since we modified the substring to have the length of the substring times 2 elements, we need to again divide by 2. But we can use this index, which is sitting at 6, I believe. 3, 4, 5, 6, to get the midpoint here. And then we would want to return all the elements from the midpoint to the length of the center. The length of P. The length, it is length of P. Length of PI divided by 2. So index of here minus the length of PI divided by 2, and then the index of here plus the length of PI divided by 2. And then in Python it would be / divided by 2, because you don't want a float or anything. So yeah, this one was probably hard to follow, but there's a good video on YouTube that I was trying to emulate here, and I will find it right now and mention it so that you guys can take a look at that if anyone ever watches this. And open up my history. Longest palindromic string. Yeah, this video is by I Deserve. That's the one I was following. And it's 23 minutes long. It's manachers algorithm. So just look up this on YouTube. You'll find it. Thanks for watching.